Right? A system of equations, what I'm going to be looking for here with three variables is I'm looking for an x, y, z value. I'm looking for x, y, and z. Usually you look for x and y, but now we have a z value. So when you ever have a z value, to solve it, you need actually three equations. And here's the process. Basically, you want to choose two equations out of the three and cancel a variable. And then choose two new equations and cancel the same variable. Now that might not make sense, but basically, with some practice, you'll notice in this situation, z is probably your best bet to get rid of. Because right away, can I cancel z by adding those? Yes. Then, I could choose two equations and cancel z again with two new equations. You'll see. So I'm going to take the first two equations, the first and the second equation, and what I'm going to be doing is I'm going to try to cancel z. With practice, you'll learn to watch and figure out which is the best equations to choose and what letters are best. There are a lot of choices you're going to have to make on these problems, but they get easier the more you do them. This one's a really nice problem because z just easily cancels. Z is gone. That gives you 6x. That gives you positive 1y. And that gives you 9. This I called my fourth equation, just to keep track of things. You're going to get a fifth equation as well. By the way, this is your first, this is your second, and this is your third equation. Are we okay with that? Now we have a fourth equation. Okay. Over here, we can't use the first and second again and cancel z. I need to use either the first and third or the second and third. Now, the first and third would be your best bet because that's a positive and that's a negative. But I'm not going to do that. I'm going to do the second and third, and I do have a reason for it. But for now, we're going to do the second and the third equation. Got it? Now, the second equation. The third equation is going to stay the same. But up here, I'm going to take the second equation real quick. Take the second equation, and I'm going to rewrite it. What do I need to multiply the second equation here so the z cancels out? That's my question. What you need to notice is I want to multiply the second equation here and rewrite it here so that I can cancel the z's. So I hear some people saying negative 3 would be a good choice. Because negative 3 times x will give me negative 3x. Negative 3 times 2 will give me negative 6y. And negative 3 times negative z is positive 3z. And negative 3 times 5 is negative 15. Was that a good choice? Yeah, my z's are gone. That gives you negative 1x. That gives you negative 3y. That gives you negative 10. What do you think I'm going to call this equation? My fifth equation. So, recap. I did these two. I did the first and second, cancel z's. I did the second and third, cancel z's. Could I have done the first and third? Yes, it probably actually would have been even easier. But I have a reason why. Okay, do I have x, y, or z yet? No. But looking at these two, I can find x and y, can I? Isn't that a system of equations with two variables? So now we go back to our original method. Okay, I need to multiply one of these by something so that I can cancel. So either it'd be easier, like we have a negative 1 and a 6, or a negative 3 and a 1. Would it be probably easier to multiply this one by 3? Yep. So if I take the fourth equation, and if I multiply it by 3, Got it? I'm going to end up with 18x plus 3y equals 27. Again, that's my fourth equation. And then aren't I just going to take this one, my fifth equation, just put it underneath? So, again, I multiplied my fourth equation by 3 so that I can cancel a variable. I took my fourth and fifth equation, with my fourth equation rewritten. Y disappears. That leaves me 17x, and this leaves me 17. What is x? If you divide by 17, you get x equals 1. So are we close to our answer? We have one piece. How do we find another variable? Now all we have left is y and z. Now let's think about it. If I want y, could I just plug this into one of these two? Yeah. Now looking at these two, what's easier? Wouldn't 4 be easier because y is chilling right there? So I'm going to take the fourth equation, and it's 6 and blank for x, because I want to find y. And what am I going to plug in there? Looks like this 1. Aren't I going to plug the 1 in for x? That leaves me 6. 6 times 1, 6. And we minus the 6 over. And it looks like we get y equals 3. Okay. So we have x and y. We have one more letter to go. What we need to do here is we want to choose one of the originals, one of these, plug x and y in, and we can solve z. Which one looks easiest? Second? Yeah. Isn't z easy right there? Look at z. He's nice and pretty. I'm going to go with the first. We're almost done, you guys. Real quick here. 5x minus y plus z equals 4. And what was x? X was 1. Y is 3. Can we easily find z now? Yeah. So that's 5 minus 3 plus z equals 4. Looks like we have 2 plus z equals 4. So if we minus the 2 over, we got z equals 2. All that together, my answer is 1, 3, 2. X, Y, Z. Again, this is the answer. You first choose two equations and then another two equations, but cancel the same variable. Get your fourth and fifth. Solve your fourth and fifth equations. Take that, plug it into one of those two. Find the other variable. Take these two variables, plug it into one of the originals. Find the last variable. Make sure you write it in the proper